Hello guys, welcome back to the channel for another Databricks video. Today's video would be about performing historical load or reloading all data when it's necessary, of course, in Databricks using Delta tables. Although this is a very important topic, I have not seen a similar video online or on YouTube, but I believe every data engineer should know about this because it's part of his daily job. If you are an experienced data engineer, I'm pretty certain that you have seen a similar technique, maybe in different systems, but when it comes to Delta tables, it was something new to me, and it took me quite a while to wrap my head around this new concept. So I would like to share this knowledge. Don't get discouraged if you don't get it immediately. It will take a while, but you have to run the code and execute the code step by step after this video in order to see how exactly it works and how you should use it. Before we jump straight into the code, let me share some slides because it would be easier for you to understand the concept and what we are trying to achieve. Okay, so normally what you will have is a workflow that runs every day or every week or every few hours. And remember, again, we are talking about batch processing here. So you have, let's assume that we have a source table with record 1 and record 2, and that is version 0. Remember, we are talking about Delta tables where we have versioning and we can time travel between versions, etc., etc. So we're going to move the data from the source table to the target table. Now, what we have to do is actually create a log directory to keep track of the versions that we loaded. For example, here, as you can see, we have the log directory that has version 0, which is the version of the source table, and we have an event date timestamp that we keep track of the time. Now, the target table, in our example at least, first we are going to create an empty data frame, and that would be version 0 with no data, so that would be version 0. And then when we append the data from the source table, that would be version 1, and it would have record 1 and 2. So target table, two versions, 0 and 1, with the same data as the source table. The source table is version 0, and the log directory has version 0 to keep track of the versions that we have loaded. Perfect. So here, let's say we append new records. Let's say we append record 3. So the source table has two versions now, 0 with record 1 and record 2, and version 1 with record 1, record 2, and record 3. Now, when we load the data to the target table has three versions: 0, the empty data frame, 1 with record 1 and record 2, and version 2 with all the data, row 1, row 2, row 3. And now in the log directory, we have two versions, 0 and 1, which means that we loaded the version 0 and 1 from the source table to the target table. So what we do here is actually compare the source table version with the log directory version. So, for example, before we load the data, what we have to do is compare the version of the source table, which is 1, and the version of the log that we have in the log directory, which initially is version 0. So 1 is greater than 0, then we can merge, insert the data to the target table, and also create a new entry in the log directory with the latest version that we loaded from the source table to the target table. Now let's say something happens and we deleted row 3, or we deleted some data, it doesn't really matter, but we want this data. Something happened, someone deleted accidentally the data, or the source changed the data and we want to reload the data. What do we have to do here is actually something very simple. We delete the log entry with the version that we want to reload. So for example, if we delete version 1 from the log directory and then we run our code will compare again. Version 1 in the source table is greater than version 0 in the log directory, so we reload this version. What we try to do here is we compare the version that we have in the source table with the version of we have in the log directory, and then we get the partitions only for this version and reload those data, those partitions, to the target table. So this is how you can do it, how you can reload the data. Of course, the target table, if you reload the data, is going to create a version 4 with the data again, because it would be an append or merge or etc, etc. So the target table will have more versions, but we don't care about that. We care about the versions that we have in the log directory and in the source table. It's a very basic comparison between the version of the source table and the version of the log directory. So what we do is just actually delete an entry in the log directory, and then this comparison will take place and we are going to reload the data that we want. Again, there are two more cases. So for example, if the source table version is less than the log directory version, that means someone deleted data in the source table. So then we perform a full reload in this case. And the other case that we perform a full reload is when the log directory it's empty, so someone deleted, or either it's new log directory or someone deleted the data in the log directory, so we perform a full reload again. So we have those three cases that we are going to see in the code. Okay guys, so let's get down to the nuts and bolts. This is the code. And here what we are going to do, the first thing we are going to do here is actually create some fictitious data, as you can see. Let me run this code. From an RDD we create a data frame and we have those records with ID, department and value. The date key is a very important column here, guys. This is the partition column. Usually you have a date column, maybe it's a date key, maybe it's a timestamp or whatever, but usually we have a date column. So let's say that date key for us is the partition column, and the other ones, the other columns are, as you can see, pretty self-explanatory: ID, department, and value. And let's write this data frame to, let's save this data frame to this container here. I have created a demo container. As you can see right now it's empty. So if we run this command, which is the data frame.write mode, append mode, format, delta format of course, partitioned by the date key, and we save the data into this location here in our storage account. Let it finish. And now we can select, we can see, of course, if we refresh here, you will see the source data folder, and if you select the data from this folder, we can see the data. And also let's describe the history of this table. It should have only version 0 because we only, as you can see, it has version 0. It was a write operation, mode append, partition by date key. So, as you can see, we have only version 0, which is very important, you will see. Now, we have the source table. And here is the actual code. We will go step by step, but first let me run the whole code and see what we would like to achieve here. We provide the input directory, which is the source table, the log directory, which is this one, the the partition keys in a list. For example, here is date key, but you might have multiple partition keys. And here we have the primary key in a list. Maybe you have multiple, a composite key, multiple columns. That's why this is a list as well. And the partition key for the target table, which is date key. And of course, the target table directory here in the storage account. Then we can have multiple modes. Here we are only going to use merge. We can have merge, append, replace where. If you want, replace where is for exchange partitioning. So we are not going to see that today, but we are going to use a merge, simple SQL merge statement to move the data from the source to the target, right? First, we need to provide the source schema, so we use struct type, and then struct field ID, which is an integer, department is a string, struct field value, which is an integer again, and date key, which is an integer. So the first thing, we have to create an object of type changes, and we provide the input directory, the log directory, and the partition key. So changes, let's go to this class here, which is this one. So in this class, we determine the changes that happen on a delta table to only process the changed data. So the purpose here of this class is to provide a list of the partition values, date key, week key, that have changed data. So, for example, this is date key. Now, this is to determine which date keys, which partition values you want to merge to the target table. So that's why we have this class. Here we need to provide the log schema, which is version, and event type, which is of timestamp. Version is integer type, of course, and it's this log schema here, and the log directory, as we said, it needs to have the same version with the source table. Determine modes that could be merge or append or replace where if you use exchange partition, and in the init here function, we provide the input, the log directory, the partition keys, the change partition keys that we are going. This is a list that we are going to return, and the partition key that we pass here. The first thing we do, of course, is retrieve the current version of the source table data. Now, how can you do that? Pretty easily with a SQL statement, describe history. You provide the source table, of course, where the operation equals write or merge, and you select the maximum version and you get the first one. So if you go up here to the describe history, we will have, where is it? Yeah, here. So version 0, operation write, and then you just select the maximum version of this table here. You are using an SQL like we have here, right? So let's go back. So we select the maximum version of the source table, and then we select the last version of the log directory version column. So here, for example, we provide the log directory path, and we order by event datetime, which is the current timestamp when we insert a record, and then we select the latest version. And then, okay, so here, as you can see, we have one exception if the log directory is empty. So as we said, if the log directory is empty, then we perform a full reload. And that's why we have table version equals to -1. Or if someone deleted some versions in the source table, then again we perform full reload, as we mentioned in the slides. Okay, so we have initialized this object here. We have passed the parameters that we want, the input directory, which is the source table, the log directory, where we are going to create the table that keeps track of the version that we loaded to the target table, and the partition key. And we have the latest version of the source table and the latest version of the log directory. Now, the next step here, let's go back to the main code. We instantiated the changes object. The next thing we have to do is actually here, we want to use this determine function based on the object that we created here. We pass the mode, which is merge for us right now, but you can play around with other modes too. And we provide the load from partition key. Just I provided an old partition key, so that means we are going to reload the data from this partition key onwards. If there are any changes, of course. So let's go back to the determine function, which is this one. Here you can see we provide the load from, mode is merge, and here we use the load from, we convert it to string, and we put it on a list. If the mode is not within the modes that we defined, which was up here, so here we have two modes. So if the mode that we provided is not in this list, we can throw an error, if you like, of course. And then we say if the mode is in append or merge, then we use this underscore determine underscore merge append function. So if we go back here, this determine merge append function will determine which partitions have changed in the source table. So if the table version is -1, that means that we perform a full preload. So we want all the date keys from the dataset. So we have this get all partitions function. We don't do something exquisite here, just we read from the source table, we select the date key column here, that's why we have the self-partition key, the partition key column, whatever you have, then distinct and collect, and we return a list with all the date keys in our example, all the partition keys from the beginning, because we are going to perform a full reload. Then, if else, we have the new versions that got changed. So what we do here is, again, we use the describe history command. Here we select the versions that are greater than the versions that we have in the log directory, and here is the comparison between the source table version and the log directory version that we mentioned before. This is the logic, and then when it comes to the operation column, it has to be a write or a merge or append, apparently, and we select the version. And this list here will provide all the date keys with the changed data. So, and then if this list is greater than 0, of course, we want to have the delta log files. What about the delta log files and why do we need them? So if you go back to your code, to your source data, you will see every delta table, of course, as we know, it has a delta log folder where we keep track of the transactions. That's why, which is pretty amazing. Apparently, this is the extra layer that provides all those benefits we have with the delta table, you know, and how we can time travel between versions. This is the delta log folder. You will see that here we have a CRC file and a JSON file. We will see that in a bit. So we want all these delta log files, and we want to actually check the delta log files. As we said, they keep track of all the transactions, and if we append new data, then in this JSON file that is automatically created, there is an add column, you will see. And if this is and if there is an add column here, that means that we have new data. Then we want all the partition keys of this that exist in this column. Else we return an empty list. You will see more details about this when we run the code. So back to the determine function. Here I have used some print statements so we can debug the code, but here is the actual code, which is nothing else than we are calling this determine merge append function that helps us determine which date keys have changed and which data we have to reload. So it returns a list of date keys. And that's what we return here, a list of the changed partition keys. Pretty simple. So then we use those partition keys to load the data from the source table. So from the source table, now we have a list with the changed partition that we determined here. That's in the determine function. We have this logic that compares the versions between the source table and the log directory version, and then gets all the partition keys that have changed data, and we return a list. And then we are using this list of date keys to select the data, the changed data from the source table, because we don't want to perform a full reload. We just want only the data that changed, right? And here we have a merge class. We provide the source schema, the primary key of the output table, and the partition key for the output table, and the path for the output table. And we use the execute function to actually perform the merge statement. So if we go into this merge class here, which is up top, here in the init, we have the schema, the primary key, partition key, the path for the target table, as we said. And what we do in this execute function is first we check if there is a delta table. So if the target table does not exist, using this override output schema, we create an empty data frame, and we save this empty data frame to the as the target table. So we create an empty table, right? And that would be version 0, as we mentioned, with no data. This is only for the first time. So if the delta table does not exist, create a new one using an empty data frame. If the table already exists, then load the data from the target table, and then we create a temporary view for the source data and temporary view for the target data, and then we get the columns here from df.schema.json value. You will see I have used this print statement, so we will see what this JSON value here provides, but actually we just get the column names of this data frame. And then in the merge statement, I have printed the merge statement. We use the merge condition function, which is nothing else than combining all the conditions, like on ID equals source ID equals target ID, or source date equals target date. This is where we jump based on which fields are we are going to join the source table with the target table for the merge statement. And when column matched, again, just to make things more generic, we use this function which provides the columns when matched what we update, and when not matched the columns that we need to insert the new records. And this is the actual SQL statement here. But as you can see, I have printed it so we know what we are going to do. And here, so we have two classes, one to determine which date keys, which partition keys have changed, and which data to reload. And then we have the merge class that actually executes the merge SQL statement. You can make it even more simple than that, but this is a generic version that you can parameterize, so you don't have to be very specific here. And then after we perform the merge statement, what we have to do is create a log record. So if we go here in this function, which is under the changes class, here we create a data frame with the latest version that we loaded to the target table with the current timestamp here, and save it to the log directory. So again, we have three tables: source table, log directory table that we keep track of the versions that we loaded, and then we have the target table. Let's run the code and see what we get. So the code is running. As you can see here, we print the date keys that have changed data. And here, this is the list of the partition keys that have changed data. So initially, remember, the source table has 8 records. If we go back to the source table, it has 8 records. And all this, if you select a distinct of this column, this is what we do actually. You can see we have like 5 or 6 distinct values here, date keys, that we want to load to the target table, right? This is very simple. What we are trying to do is very simple. We select all the date keys that have changed data. Since we didn't have anything to the target table, we have to load all the data from the source table the first time. So partitions to load, that's the partitions to load. The schema of the output, remember I told you here where we have this code that we print the JSON value. So here we just select the columns, and the print statement is actually this one, the schema of the output. From here we select the ID, the department, etc., and then we create our merge SQL statement. As you can see, it's merged into target using the source based on the ID, and when matched, then we update all the columns. Basically, when not matched, we insert the values. Now here, if we select from the target table, which is this one, so now you can see we have the same data that we have in the source table. And if we describe the history of this table, you can see we have version 0, which is a write, and this is mode append, and this is where we didn't insert anything. It's where we created the empty data frame, and we inserted the empty data frame to the target table, actually to create a target table. That's why you see that the number of files changed is 0. And then we have version 1, which is a merge operation. Remember, we performed a merge, and with all those conditions here, and we changed number of files added 6, right? So we've done that, the first load. That means we load the data from the source table to the target table the first time. Let's see the log directory. Actually, it should have the log directory. So if we select the data from the log directory, you can see it's version 0, and this is the event datetime. So version 0 in the source table, version 0 in the log directory. Let's append some new data to the source table. So let's use this one, and this is the new data, right? ID 6, ID 7, with those date keys, and then let's append this data to the source table. Let's append this data, and then let's select from this source table. Now we have 10 rows, and with those those two are the new records here with those date keys. So now that we will re-execute the code, it should only load these two records, right? And we should only select from the source table only the date keys that have changed data. And here that means these two date keys. So let's re-execute the code, see what we get here. Now, again, as you can see, we have those two partition keys that change, only those two, only those two partition keys that change, right? So only two records, and then we update the target table with only those two records. We get the delta changes essentially. We just do not reload all the data, we reload the data that we want. Now, if you go into delta log files in this JSON, the first JSON, or if you go into the second JSON, actually, no, it's actually we display the same thing here. You can see there is an add column where it has the partition values, and here we have this partition value, which is for one record, and then the second, the second has this, and then we have the second partition key, which is this one. So two records with different partition keys, and in the delta logs, we have this JSON automatically created, and then we want to get the partition values from this add column here, and then load the changed data only. That's why we want these JSON files that are created under delta log. Now, if you go back to your Delta Lake, you will see in the log, in the source data, yeah, we see that we have this delta log file, and here we have this JSON, the first JSON and the second JSON. So every time that we have an append, we have a new JSON that says which columns, which data has been appended, and that's why we need to use those JSON files here to select only the partition keys that have changed data in order to merge the new data to the target table. So if you see now the target table, it will have 10 records, at least it should have 10 records. Yep, we have 10 records. If we describe the history of the target table, we have version 2 here, so 3 versions, and then the merge operation as well with all these, the number of files that we have added, number 2, right? And in the log directory, now we should have version 1. So let's select from here. We have version 0 and version 1. The same happens with the source data. We should have only version 0 and version 1 because we only performed an append operation, 2 eyes. So now let's say that we want someone accidentally deleted the data to the target table. Here's the data with all those IDs. Now let's delete the data with ID greater and equals to 5, and that means, so let me delete this data here from the target table, right? And let's see how we can perform a historical load, which is the purpose of this video. Now let's select again from the target table. You see we are missing records. How can we perform a historical load? It's pretty easy. So we go here in the log directory and we delete from, let's say, version 1, and let's delete only version 1. And here, if we select from the log directory, you will see we have only version 0 now. And what the code does is actually compare the version between the source table and the log directory version, and then we only reload the version that is missing in the log directory. So now when we run the code again, it should only merge to the target table only the 2 records that we have in version that we appended later on. Let's see what we got. The code run. Let's select from the target table again, and we should have 6 records. Remember, right, because the last write operation in the source table only had 2 records. And this is how you can perform historical loads. Now, if you want to reload all the data, you just delete from all the versions that you want to reload from that point onwards, and then execute the code again here, and that will reload all the data from the beginning. And now in the end, when this is done running, we should have the target table should be synchronized with the source table, because it's a merge, not an append, to the target table. And we should have 10 records. Yeah, we have 10 records, all the records that we have in the source table. Guys, I'm going to wrap it up here because it can take hours and hours to debug the code. I'm going to leave that to you. I will upload the code to GitHub so you can go through it and do it yourself. Just remember, if we zoom out, the logic is pretty simple. We have 2 classes, one that returns the partitions of the changed data based on a comparison between the source table version and the target table version and the delta log files, and the second class where we execute the merge statement based on the conditions that we provided. So to perform a historical load, we just delete the versions we want to reload in the log directory. I know it's not simple to understand the code, it can take hours, but it's one of the most important topics when it comes to batch processing with delta tables. This is something that can be asked in an interview as well, so it's good to know the concept. If you like the video, please click the like button, leave a comment, subscribe to the channel, and I will see you in the next one. Thank you.